Welcome to this video about lung pressures. Today we're taking a look at the different pressures that control the properties of the lung. We will cover alveolar pressure, intrapleural pressure, and lastly we'll take a look at the transpulmonary pressure. I will try to explain it as straightforward as I can, and I will show some visualizations to help you better understand how it works. Let's begin. Here we see an illustration of the lungs, viewed from the side. Now inside the lungs, we have the bronchi and the alveoli. And inside the alveoli, that's where we find the alveolar pressure. And surrounding the lungs, there is a pleural space filled with pleural fluid. This is where we find the intrapleural pressure. And the transpulmonary pressure is the pressure difference between the alveolar and the intrapleural pressure. Now, don't worry if the intrapulmonary pressure sounds a little bit too complicated to understand. We will break it down later and look at what it tells us. But first, let's take a look at the alveolar pressure. This is the most straightforward pressure. It's simply the pressure inside of the alveoli, and it dictates the flow of air. If the pressure is higher in the alveoli compared to the atmospheric pressure, then air will flow out of the lungs. When the alveolar pressure becomes lower than atmospheric pressure, then air will flow into the lungs and we will inhale. Now, if you want to learn more about what forces and muscles that change the alveolar pressure to control inhalation and exhalation, you can take a look at my video about inspiration and exhalation in the card above. But let's take a look at the intrapleural pressure. The intrapleural pressure is normally negative, around -4. And the alveolar pressure is usually higher than the pulmonary pressure. In this example, we say that it is +6. This causes the air in the alveoli to exert a pressure that will want to expand the lung into the pleural space, where the pressure is lower. However, the lungs have contractile elements to cancel out this pressure force and keep the lungs in a resting state. But if we were to increase the pleural pressure, for example in cases like pneumothorax, where the pleural space becomes equal to the atmospheric pressure, then the contractile elements of the lung no longer have this opposing force to keep the lung in an equilibrium, and the lung will collapse in on itself. And this explains why the intrapleural pressure is normally negative. Lastly, let's showcase the importance of transpulmonary pressure. When we understand the alveolar pressure and intrapleural pressure, then it's easier to understand the transpulmonary pressure. Transpulmonary pressure basically shows us the force of the pressure that tries to expand the lung. For example, if there is a large difference between the alveolar and the intrapleural pressure, then the transpulmonary pressure will be high. In this example, the alveolar pressure will want to expand the lungs significantly because it's much higher than the intrapleural pressure. And normally this will exceed the contractile elements and cause the lung to expand. However, in cases of restrictive lung disease, the contractile elements are increased due to fibrous tissues. And then the transpulmonary pressure is usually high without any lung expansion. But on the other hand, if we decrease the alveolar pressure so that the intrapleural pressure becomes higher than the alveolar pressure, then the lung will experience a negative expansion force and it will collapse, just like in the pneumothorax example. And that concludes everything for this video. I hope you learned something. And if you did, consider liking the video and subscribing.